Hey everyone, welcome to part 7 of my ZZ tutorial. This is the final part, and in this part I'm just going to discuss ZZ for other things besides 3x3 speed solve, mainly one-handed, feet, and larger cubes. Afterwards, I'll just quickly talk about what I think or what I hope will happen to the method, and just talk to you about my feelings on the method as a whole and conclude the series. Let's first talk about one-handed. Right, so I'm going to talk about ZZ for one-handed, and obviously on paper, ZZ for one-handed looks amazing because the F2L is 3 gen, and you can really be comfortable when you solve the F2L. Unfortunately, what people don't recognize is the difficulty of the EO line. It's actually quite difficult at times. So a lot of people run into that kind of issue when they do ZZ for one-handed. But with the proper way of thinking and the proper adaptation, ZZ for one-handed isn't too bad. So what I'm going to do is like randomly scramble this cube, just hand scramble, and just show you guys a ZZ adaptation for one-handed. So the EO line, you don't have to execute from your solving orientation. In fact, all my EO lines for one-handed are executed from a different spot. So in this case, I have this wrong edge, this wrong edge, this wrong edge, and 1, 2, 3 in the back. So I have 6 wrong edges. So I'm going to orient these 3 like this, rotate, and I notice that this piece is opposite. So when I do this, they will be opposite, and this cross piece is solved. So what I'm going to do is rotate like this, and rotate while I'm turning like that to solve the EO line. And I noticed that this piece is already in, so this was by accident. So I'm just going to leave it alone. And these two pair, so kind of like this. And keep in mind that sometimes a Z rotation will be necessary to solve the cube, comfortably that is. And the thing with the Z rotation is that if you're already rotated Z, you might as well just do something else while you're rotated so that you don't rotate back and forth. That's an issue that I experience a lot, so I'm just going to stay like this to form this pair, and I'm going to insert it, and I see this pair over here, so I'm going to stay rotated like that. And this one is CLS, and it goes into a Y perm like that. So accidentally solved ELS was really nice, and it gave me pretty much a pair skip, and I did the left block entirely from a Z rotation, so I conserved rotations. So the gist of one-handed solving with ZZ is to conserve rotations and really be smart with your EO line. You don't want to start your EO line like this. I know I stressed that for two-handed, but it's an even larger issue for one-handed since you only have one hand. So if you're going to start ZZ one-handed, I highly suggest being familiar with two-handed first and really be able to think through your EO line, because you will have to first come up with an EO line and then come up with a way to do it comfortably. And that is the challenge behind ZZ one-handed. But once you get that out of the way, the rest of the solve just flies, and it's very comfortable. And I'm really happy that I used the method for one-handed. I think it's given me a lot. So I hope you guys can just take these suggestions to heart when you practice, and I'm sure you'll learn a lot about yourself doing ZZ one-handed as well. Again, not a lot of people do this method, let alone one-handed. So if you start now, you will be one of the first. All right, so I'm not much of a foot solver, as many of you know. Instead of telling you what I think about the method, I'm just going to talk to you about what other people have said about it. When I go to competitions, I always like to talk to fast foot solvers about what they think about the ZZ method. And many of them said that it could quite turn out to be a really, really decent method because of its two-gen characteristics and how simple the last layer can be if you, of course, choose the right alg sets. And who knows if foot solving gets really, really crazy and a one-look last layer makes a difference, then perhaps ZZ will be, one of the really, really nice foot solving methods because it has a practical last layer approach. So yeah, who knows? If you have done ZZ with feet and have your own experiences to share, highly recommend you post a comment and let everyone else know how it went because I think everyone is curious to see how ZZ can be used in other ways besides 3x3 speed solve. And feet just happen to be a funny way or just a funny event to think about how to adapt a method. So again, if you've done feet with ZZ, just feel free to comment and let everyone know how it went. All right, so let's talk about ZZ and what it can do on larger cubes. The thing with ZZ is that it's very, very reliant on inspection. And you can clearly see that because before you actually do anything, you have to know where all the wrong edges are. So if you don't know ahead of time and say you reduce a 4x4 to a 3x3, you're in a lot of trouble because you have to decide what to do, but you don't know exactly what you're working with. So that's the issue with ZZ on larger cubes. It doesn't quite work out unless you adapt the larger cube, I guess, method to ZZ. One example of such an adaptation is the method called Z4. It was developed by Conrad Ryder, who is the author of that wonderful text tutorial I keep referring to. So what Z4 does is it orients the pairs of edges while you pair them. So you get to skip orientation parity, which is really cool on a 4x4 because I know a lot of people get frustrated when they have to deal with parity. Uh, but the method, again, as most other variants of ZZ, aren't very developed by solving, so not a lot of people solve it. Usually when people solve using a method, they can give feedback and suggestions, and I don't think the method has been used enough to kind of develop that way yet. But there is documentation on it, and I will provide it in the description for those of you that are interested. I don't think any ZZ adaptations for cubes larger than 4x4 have been made, like 5, 6, and 7, and so on and so forth. But if you have any cool ideas and you're really creative with method development, feel free to, just think about it and see what you can come up with. The main issue with big cubes is that you have to somehow find a way to know where your misoriented edges are before you start acting on it to create an EO line because you don't want to waste time looking for your EO line building blocks. So that's the main idea of ZZ for big cubes. It's kind of difficult to adapt because the solving is so much more abstract. Again, if you have any ideas, feel free to comment and we'll talk about those ideas and hopefully, you can make a new method for big cubes. Okay, so this is the last segment, and it is titled "The Future of ZZ?" question mark. And I have the question mark because I cannot predict the future of the method despite being really interested in using it, teaching it, and developing it. So what I can do is talk to you about where I think it's going and where I hope it will go. So let's get into that. For starters, for two-handed solving, I think ZZ has a long way to go before it could catch up to users of other methods. So I'm talking about users of the ZZ method versus users of the other methods. Mainly CFOP and RU. Those two methods already have really ridiculously fast users, and their speed is just mind-blowing. And we do not have a ZZ user that currently that can currently stand up to those guys if they were to say compete. But I'm hoping that there will be one in the future. I don't think it will be me because I'm just so behind on two-handed solving. But in all seriousness, I hope there will be one in the future, and hopefully that will inspire other people to consider the method because what's realistic is it's really hard to convince yourself to spend hours, days, weeks, months, years to practice a method when you haven't seen someone do it really, really fast. And I don't think people are convinced that it will be rewarding in the future, because people now are getting 7 averages, and they're nearing or have already broken 7 averages at home. So, and no one has ever seen a ZZ user get even close to that. Um, so I think that's one of the reasons why it's not used so much. But I hope someday there will be some individual that will step up and kind of inspire other people to try out the method. I think it can definitely become fast. I think one look last layer can definitely be a reality, and I think that ZZD will eventually be more mainstream, and more people will take a look at that missing link, and perhaps years from now that link will not be so missing as it is now. In terms of one-handed, I think it's a really outstanding method, and it's already competing with CFOP. Not so much on a really large scale, because I'm only one person, and I'm currently the only person using it competitively for one-handed. But again, I hope there will be others in the future, and I think that if one-handed gets really, really crazy, I suggest people resort to checking out the ZZ method, because sometimes it can really help in certain situations. And I'm just going to be direct with this. I think the ZZ method is better than CFOP in certain situations, and I also think that CFOP is better than ZZ in other situations. And it really shows sometimes, depending on the scramble. Sometimes when I'm at a competition and I'm chatting with some friends, and we both are waiting to solve, we go up there and we do our thing and we come back, and I go, man, that scramble was crazy. Like, I just couldn't get anything good out of it. And my friend goes, well, that was kind of good. I had a good cross. And I get frustrated because, other people have such a good start. Why can't I find one? Well, the EO line was just plain hard. It either was too long or too abstract, and I couldn't see into the F2L. And sometimes the EO line is really, really simple, and I get to see the EO line in a block, and people who solve cross don't get such a head start, and so I end up beating them if the EO line is easy. So I think it goes back and forth, and for one-handed solving, I think considering ZZ as a secondary method for CFOP users is definitely useful if you have the time to invest. I know there are certain individuals that are already doing it and considering doing it for one-handed. I know back in my day, when I first started, I didn't have many, many resources to look at. In fact, I kind of just learned everything on my own and made a lot of mistakes, and I had to adjust it as I was going. But now there's so many more resources, people can really avoid making the same mistakes I did when I was first starting, because I was just not very well informed when I first started. So that's the thing with ZZ. I hope it continues to grow. I hope that this tutorial will inspire other people to try the method, get good at it, and I hope those people will kind of give back to the method and really, really incorporate what they think could happen in the method into some sort of educational tool, perhaps, and just show everyone else how they've been doing it, because I think that's one way a method grows. So, in conclusion, this tutorial series was really time consuming to make because of all the examples and all the talking, but I really enjoyed making it. This is definitely not the last video I will make, despite me taking a break from competing. But I'll continue to hang around, I'll continue to solve using ZZ, and I'll continue to interact with as many people as I can. Thank you very, very much for watching, and as always, if you have any questions, feel free to ask anytime, and we'll talk about answering that question. See you guys later.